Hey friends, welcome back to this mini-series. This is the route leaking in the wild on Cisco iOS XR. It's a SaaS scenario. We're going to continue following ZigZagZoo around the park here. This is going to be our development enclave, and we're going to do our IP addresses and our server configuration for how we want our development enclave to be set up in this scenario. So what we've done so far is we have our production network set up. So here, parts from 1 through 4, we set up our production devices, we set up our production IP addresses, and then we set up our production IGP, Interior Gateway Protocol, OSPF, and then we did our eBGP. So we did some eBGP, we did some redistribution, and then we also injected some static routes and a default route all the way down to our production switch here. And we validated all that every step of the way, just to make sure we did something, we validated it. We did something else, we validated it. That's the whole process we're talking about here. So now what we're going to do is we're going to go ahead and build out our development enclave. Very similar to our production enclave. We're going to go ahead and build out our development enclave because if you remember the ZigZagZoo scenario, the whole point of this is that they wanted a development enclave so they could do dev test and not affect production. They could go quickly test something, right? That's the driver. They want to be able to quickly test something that doesn't affect production, but they still need to access some of the production resources, some of the shared services, like time, maybe, or AD, Active Directory, or DNS, or DHCP, or probably not DHCP in this situation. But there's going to be some shared services they need access to, and then also internet, which is also a shared service. So let's go ahead and jump right in. Here's where we are today. Now here is our updated diagram and the situation that we have with a development environment. So we're going to add 3 devices here. We're going to add a dev RTR, dev router. We're going to add a dev switch. And then we're going to add a dev server. So really simplistic. We're trying to keep it really clear. That dev RTR is going to connect to our core router. Our core router is going to become kind of our main device. That's why we named it core actually in the beginning. And then today we're going to go ahead and configure our IP addresses. And the next part, we're going to configure our IGP. And then in the final part, we're going to do some route leaking, right? All right, let's go ahead and get into the command line and configure these devices. All right, so here we are in our CML topology. And we're going to go ahead and add some devices here. And like I said, we are really just going to add the same devices we already have, iOS V. Add one iOS V, and then we're going to add our iOS L switch, and we're going to give ourselves a name like we did before. So here again, this is going to be our dev, and this is going to be RTR, and this guy is going to be our dev switch. So there's those. We'll kind of keep them there for right now, and then we need to add our server. All right, there's our server. We're going to give that guy a name too. And then we'll start these devices. All right, let's go ahead and connect them first though. We can't start them until we connect them. We got to connect them up first, huh? All right, so I'm going to map the ports directly to what I have in the topology diagram here. So on my dev RTR, it's 0, 0. And then on my core RTR, it's 0, 0, 1. Now this display isn't accurate. It just doesn't have the extra lines there. All right, and we're going to add our connection going down to the switch, our dev switch here. So this is going to be gig 01. And on the dev switch side, it's gig 00. And then one last connection from our dev switch to our dev server. And this is gig 01 to ETH0. All right, our connections are good. So we're going to go ahead and start these guys. So something to note, because we do have this other kind of enclave, we have to use a different subnet range, different routing processes, and all these things. So for our IP addresses here real quick, we have our 10.20.0.0/16 range. That range is going to be dedicated to our development enclave, which is different than our production IP address scheme, which was 10.10.0.0/16. And this is going to be the same process as we did before. We have identifiers for these new devices. So dev RTR is an ID of 5. And then our dev switch down there is ID of 6. And then our dev subnet that we are going to end up creating is 200.200.200.0/24. And our dev server is going to have that 200.200.200.200 address on it. All right, so it looks like our router is up. So we're going to go ahead and configure our router. And the first thing we're going to do is our host name. Same thing we did before in production. Oh, I'm dumb. Sometimes I make dumb mistakes. Host name, dev, RTR, bam. All right, so some of the things that we're gonna do on this guy is we're gonna give it a loopback address, like we have been. And this one's gonna be 10.20.5.5, because that is the router ID that we're using. Again, I'm gonna no shut the interfaces. You don't need to, it's just a force of habit thing. It makes me feel warm and fuzzy inside, knowing that my loopback address is no shut. All right, so let's configure our IP address on our gig 00 interface. That's our link to the core router. All right, so here we're going to do 10.20. And again, it's going to be our lower ID number, which is our core router 2, to our higher ID number, which is 5. And then it's going to be whatever device we're on's ID. So in this case, we're on 5. And this is going to be a /24. Helps if I... Oh, I did it wrong. Huh. It's supposed to be like that. So our third octet is supposed to be the ID combined. I do some of these labs where I have the ID in multiple octets. So like the first ID might be in the second octet, and then the second ID might be in the third octet, and then the address is itself that local device. In this case, this lab is not that way. It is actually 10.20, and then the ID is combined. So in this case, it's 25, and the actual local device is .5. I'm gonna no shut this. We're gonna put a description in here too. Connection to, sorry, it didn't let me, connection to core RTR, and this is on gig I 0/0/0/1. And one more, there we go. All right, one more interface to do here, and this is going to be our gig 01 interface. We're going to do that description real quick while we're here. So this is going to be going to switch, so it's dev switch. I'm going to do an underscore here, but I'm probably going to name it with an underscore, and it's gig I 00. And there's our connection there. Our IP address here is going to be 10.20, and this is going to be 56, and our local address is .5. And we're going to do a 0, no shut. And I'm just going to double check I did no shut the interface of gig 00. I did. All right, so that's our IP addresses. Pretty simplistic on dev RTR here. And we're just going to do a quick show IP in brief. I do like to use exclude unassigned, because then I don't get anything else that has an IP address, that doesn't have an IP address. And just to physically validate with a show command, a show run command, that our IP addresses are correct, or not a show run command, a show command on the interfaces. So here we have 00, gig 00, 10.20.25.5, and then gig 01 is 10.20.56.5. Our loopback address is 10.20.5.5. So that is good to go. Those are our IP addresses. And we can validate this by pinging them and whatnot, but we have to configure our other devices first before we can validate the next hop is reachable. All right, so let's jump down to dev switch real quick and do the same process here. Now keep in mind, this is a switch, so the configuration's a little different, and just keep that in mind. Our host name here is going to be dev_SW. Loopback address 0 is going to be IP address 10.20.6.6. And again, that's going to be a /32. Okay, no shut that interface. And then our interface gig 00 is going to be our link to our dev router. Connection to dev RTR gig I /0. 1, 2, 3, 4, bam. And then our IP address here, we actually are going to have to do no switch port, because this is a switching interface by default. And we want to make it a layer 3 interface. A switching interface means it's a layer 2 interface, and we want to make it a layer 3 interface. So here we're going to do no switch port, and it becomes a layer 3 interface. All right, so this IP is going to be 10.20.56.6. And again, that is a /24. All right, no shut it. And then we don't have an actual routed link to our server. So we actually have to configure our VLAN interface and our VLANs now for our dev server VLAN. So here we're going to configure VLAN 200, give it a name, dev SRV maybe works. Okay. And once that populates, then we're going to go and create a VLAN interface for that VLAN. And here we go. And again, I'm going to give it a description. I'm going to say dev server VLAN. I'm probably going to put the subnet in here too, just to make it very clear what we're doing. All right, and then the IP address is here. The default gateway is going to be .1 for this subnet. And again, that is a /24. All right, so from an IP address perspective, we should be good to go. I'm going to quickly save this, and we'll do a show IP in brief just to make sure. I did not type that right. Show IP int brief exclude. I just like the exclude. It gives everything else has an IP address. All right, so we have our gig00 interface, that 10.20.56.6, and that is accurate per our design. Loopback 0 is 10.20.6.6, and that's accurate because that's our loopback address. And then our VLAN, our dev server subnet is 200.200.200.1, and that's a /24. That all looks good. There is one thing I would call out here. Our VLAN interface is down, even though I no shut it. And I'll give you a minute if you can think why that's the case, and I'll tell you. So the reason why that is down, because there's nothing on this switch in that VLAN. There's no trunks coming off of it. If there was a trunk that had that VLAN active, that link would be up. There's no ports, no access ports that are in that VLAN currently either. So right now, that SVI, that VLAN interface, is actually down because there's no VLANs that are in the active state. There's no access in the active state. So what we actually have to do anyway is on our gig01 interface, we have to actually enable it to be on VLAN 200. And we're going to do that. So gig01, same thing as before, we do a description here, connection to dev, and we'll just do SRV, and this is on ETH0. I didn't do the 4 over there, so we're going to go all the way back and do 4 stars, because I like to be very specific. And here, we're going to do switch port mode access, switch port access VLAN 200, and we're going to do that spanning tree port fast because it will come up quicker. And I'm lazy or efficient, whatever you want to leverage today. We're going to no shut the interface too. And that VLAN interface should come up, and you can see it in the logs. That VLAN interface came right up. It's up now. Show IP int brief exclude unassigned. We should see it, and we do. Let's save that. All right, we have one more device to give an IP address to and configure some default routing on, and that's our dev server. So we are going to go ahead and jump into our dev server real quick, and we're going to set that up. All right, so here what we're going to do is we're going to give it a no host name. Dev RTR, not RTR, just do server, SRV maybe, server, dev server, and then we're going to do a sudo ifconfig eth0, did not type ifconfig, right? Ifconfig eth0, because that's our interface, and we're going to give it our IP address 200, 200, 200, 200, and our net mask of 255.255.0. Hit enter. So that's our IP address, but now we need a default gateway. We need to know how to get traffic outbound from the server. So sudo route add default gateway, and this is going to be 200.200.200.1, and we've got to specify what interface we're leveraging. All right, so now that we get all of that, we should be actually able to ping our default gateway. Now let's just double check that we have things configured correctly. If we do ifconfig real quick, we should see our interface eth0 has the IP address 200, 200, 200, 200. It is a /24. Our broadcast is .255. That is good to go. If we look at the route table real quick, we should see a default route pointing to our default gateway. It's not a default route. I want to be very clear. It's a default gateway. And we do have a default gateway here going to 200.200.200.1. That's our gen mask with all routes. And that is going out ETH0. So that is a validation of that configuration, right? So we validated, we configured it, it applied correctly. Now we're going to try and ping that final validation. So we're going to ping ourselves first, just to make sure our local NIC is operating. Just something I've always done. And then we're going to ping our default gateway. And sure enough, we can ping outbound. That is a verified good test. So now let's go to our dev switch and verify our dev switch can ping us, our dev server, and that it also can ping our dev router. Again, hop by hop connectivity. So the first thing we're going to try to ping is our dev server from here, and we can. That is good. Let's go ahead and try and ping our dev router. And that's 10.20.56.5. We'll just validate I have that right at the diagram. 5056, yep, that's .5, and we should be able to ping that address. And if we can, then we have a good connectivity there. We do. Now, we wouldn't be able to ping the loopback address because we don't have any routing protocols yet. Let's go to our router, our dev RTR, and double check that he can ping our dev switch. And sure enough, he can. All right. So that concludes our initial kind of configuration here in the dev enclave. We have configured, we added the 3 devices, right? Real simple, added 3 devices, a router, a switch, and a server. And we've done our configuration of our IP addresses on those 3 devices. In the next part, part 5, we're going to do some IGP. We're going to add OSPF. We're actually going to add OSPF with a process ID of 20. And we're going to get our connectivity running within this dev enclave. All right, so that's it for part 4 here. We've configured our IP addresses. We validated they work. We've done some show commands to validate they were configured correctly, and we verified them with ping. If this is something that you're liking, if you like this kind of series, you like this content that we're delivering, I would love if you could just hit that subscribe button. If you could hit that bell so that you're notified when we create a new episode, a new content. And then also, if you have any suggestions of something you would like to see, go ahead and hit the comments down there and add something. I am just creating content that I think you will like. And if there's something specific you want me to highlight, I can easily highlight it. All right. I hope you enjoy. And until the next part, I will see you then. Bye for now.